we need to reconsider the structural core at this height.
If we increase the diameter, we lose critical floor space.
We must finalize the height comparison immediately. The investors need to see the ambition.
It's rising now. We are clearly exceeding the benchmark towers.
As you can see, this structure represents our future. It's time to move from discussion to commitment.
Options. Reinforcing the core here increases load capacity by 20%.
But that compromises the facade geometry on.
Let's place the primary scanner here to cover this sector.
Agreed. I'll hammer the reference marker into this dune now and begin calibration.
Data confirms the location. This is the spot.
Understood. Marking the point now.
These load paths converge right over the unstable section.
We need to reinforce the foundation design as shown on the tablet.
Agreed.
The resistivity readings don't match the strata visualization.
This sand is finer than expected at this depth. We need to update the model.
The grid lines need to extend further east based on this data. All right, I'll direct the survey team to adjust the stakes immediately.
What's your reading on the north side?
Showing 0.3 meters below grade.
Here, the deep pile drilling rigs commence boring operations, driving massive augers vertically into the desert floor, extracting plumes of sand and rock.
Utilizing a unique cutaway visualization, we reveal how the foundation piles anchor the structure deep within the Earth's bedrock.
Hold it! Hold it! Okay, easy down now, easy down.
High-strength concrete is pumped through these hoses deep into the foundation piles, creating a stable base for the structure.
The structural integrity hinges on the foundation pour alignment.
We need to adjust the flow rate on the west side immediately.
The preparation of this massive reinforced concrete raft foundation is the critical first step.
The foundation stage is crucial. We must ensure the rebar grid meets the exact specifications for the structural base.
We have to maintain the flow rate shown here on the schematic. It's the only way the structure holds.
Bring it left, bring it left. Keep it moving.
Embedding these sensors allows us to monitor the concrete's temperature in real time, crucial data for large-scale desert projects like this one.
The heat today is intense. We need to adjust the curing schedule.
Let's double the frequency of temperature checks on the west side pour.
This is the slip-form system, a ring of steel and hydraulics that enables the central core to rise uninterrupted, 24 hours a day.
Using the continuous slip-form method, the core walls rise uninterrupted, a testament to precision engineering in the desert heat. The first structural floors are emerging, a testament to engineering in the harshest environment.
All right, secure the base anchors now.
Lift slowly. Watch the alignment.
The elevation chart shows we need to adjust by 2 degrees.
Setting the laser now. Beam looks steady.
Alignment confirmed.
In just 3 days, the foundation for the new cultural center rose from the desert sands. The desert landscape is quickly transformed as excavation gives way to the rising podium structure.
Watch the tension on that line. Easy now.
Near the southeast corner by the truck. Let's run the density gauge again before signing off.
All right, clear the area. Truck is powering up. Backing away from the tripod now.
Slipform construction enables the core to climb steadily upwards, a relentless ascent as days and nights blur past.
To build at this scale requires overcoming the fundamental laws of physics. Pumping concrete to these heights demands immense power and precision.
Is meticulously installed, forming the backbone of the entire structure.
We manage the repositioning of the jump form systems vertically, allowing us to move quickly to the next level.
With unprecedented speed, the central tower began its ascent, redefining the city skyline.
This wireframe highlights the critical stress points on the Spire structure.
The night crew is scheduled to reinforce that section immediately.
We have to account for the transit impact on the samples.
Yes, but the compression data should still align with the projections for this mix.
Align the pole with the edge of the setback. I have it. The elevation seems off by a few centimeters.
The integration of field data instantly updates the engineering charts, showing the floor count increasing rapidly as the structure takes shape.
This connection point is critical. We saw stress fractures during the last simulation.
We'll need the specialized climbing team to assess it directly.
The core structure represents a new era in engineering, finally reaching cloud level.
The specialized lighter steel allows for faster installation on these upper levels, critical for staying on schedule in this harsh environment.
Signal acknowledged. Proceeding to climb point. Watch the hydraulics on level 3.
Installation of the mechanical floors requires absolute precision, even in this environment. The surveying team ensures the massive hauler stays on grade.
The data from these sensors is critical. As the wind speeds increase, the oscillations become severe.
Utilizing revolutionary construction techniques, the structure ascends rapidly, narrowing significantly as it reaches for the sky.
Never before has a concrete pump reached this altitude. A new world record established here in the Golden Dunes requires precision and courage. These men work thousands of feet above the clouds.
Keep that vibrator moving. Watch the flow, don't let it back up on this side.
As dawn breaks over the dunes, the structural team confirms the completion of the highest occupied floor, a critical milestone.
Core structure fully completed.
As you can see on the schematic, these temporary platforms must be removed before we install the antenna array.
This rapid ascent symbolizes the unprecedented growth we've achieved, far exceeding initial projections.
This visualization demonstrates the projected revenue growth for the Tower Initiative.
As you can see from the projection, the cranes are now repositioned for the final structural lifts, keeping us on schedule for Q4 completion.
The installation sequence must follow this exact trajectory to avoid clearance issues.
And the bracing points here are critical for the wind shear.
Finding the precise location in this vast expanse was the first challenge. Now, the assembly of the central spire can begin.
Look, it's breaking through the surface. It's going right through the core. Get back!
Utilizing the survey coordinates, the central pylon locks into its final position. We are now operational.
In the heart of the dunes, they began work on what would become the world's tallest structure, the 828-meter tower.
Against the odds, the structural phase is complete. This convoy represents the culmination of years of work in this harsh environment. The glass curtain wall installation begins, a complex dance of precision engineering high above the desert floor. We must ensure the trajectory compensates for the wind shear at this height.
Agreed. The tolerances on these reflective panels are minimal.
The misalignment here exceeds tolerance.
We need to recalibrate the east elevation lasers immediately.
Agreed. Precision is critical for this phase.
Steady pressure on the gun. Keep that line straight. Copy that. Moving to the next panel now.
Level by level, the facade climbs higher, a testament to engineering in this extreme environment.
The exterior may be imposing, but the real work begins inside, as the crew starts the critical task of framing the interior walls.
The elevator shaft at unprecedented speed, shaving months off the construction schedule.
Cable network begins its vertical expansion, reaching for the sky.
With the crane secured, the crew begins the delicate process of raising the first vertical plumbing segment.
Okay, securing the flange now. Ready to weld.
Fire safety infrastructure is in place, even in the harshest environments.
Grid stabilization confirmed. Systems are now fully operational.
As the team begins the delicate process of interior finishing.
This schematic illustrates the proposed lighting array for the observation deck. We've just demonstrated the transition from the daylight. The projections for the Meridian Tower hotel suites remain optimized for Q3 completion.
The residential floors are nearing completion, and market absorption rates have exceeded expectations, ensuring a rapid return on investment.
With the observation deck structure successfully installed, we are now seeing significant returns, as highlighted by these graphs.
The structural integrity at this joint is our primary concern during deployment.
We've reinforced the chassis based on the simulation data.
Losing daylight fast. How much longer on this heading?
About 10 clicks. We'll need to power up the LED system soon if we want to maintain speed.
Testing sequence 1 complete.
Confirmed. All systems nominal.
Go, go, go! Get clear of the site! Move to the rally point! Look at the stress fracture on that boom housing. Copy that. Documenting for review.
According to the schematics, the bracing on level 90 should handle the velocity.
The pressure test on line 3 is showing intermittent spikes.
We need to check the flow rate against the schematic.
The readings in Sector 4 are fluctuating.
Adjusting the sensor now. Stand by for stabilization.
All right, bring her forward 20 meters. Roger that, 20 meters. Keep an eye on the left side clearance. Initiate movement, slowly.
Reading confirmed. Maintaining alignment.
Maintain visual tracking on the grid markers.
Confirmed. Stress sensors look good so far.
Final safety certifications approved.
All right, team, this is the final check before mobilization. Ensure all protocols are signed off. Everything looks good on the vehicle side.
New day reveals a monumental undertaking. This tower represents the pinnacle of human engineering.
All right, hold it right there. A little to the left. Steady. And stop. Looks good. Kill the engine.
As the workers clear the final section, the crowd surges forward, anticipating the event.
And with that, we officially commence operations. All right, let's move.
We overcame significant challenges during construction.
Our vision was to create not just a building, but a permanent transformation of the Dubai skyline, starting here.
The projections indicate a significant rise in visitor numbers.
The view is absolutely stunning. Look at the scope of the city.
This growth is directly linked to the seamless operation of the new high-speed elevators, which are performing flawlessly.
We need to ensure the structural integrity of the Spire before finalizing the suite layouts on level 70.
Agreed. We must reach the target coordinates within the hour.
This is warfare correspondent Sarah Jenkins reporting live from the Capitol, where
When placed side by side, the sheer scale of the proposed structures dwarfs even the tallest buildings on Earth. Precision engineering, charting the course for the next generation of development in challenging terrain. Day and night, through dust and heat, these crews pushed the boundaries of what was thought possible.
Ensuring the longevity of these machines in such harsh environments requires meticulous long-term planning and preventative maintenance strategies.
If we look at the structural integrity data here, we can confirm the approach.
The wind shear analysis is still showing variables at this altitude.
The golden hour provides stunning visuals, but the shifting light makes accurate surveying a constant challenge. City life begins here, beneath the shadow of a colossal tower that promises a future unlike anything seen before. The foundation for the next generation of megastructures begins here, utilizing technology once thought impossible. The foundation work required immense effort, laying the groundwork for a structure that would eventually reach 828 meters.
The journey began here, transforming the desert into a foundation for the future.